Russia tried to jam it, tried to shoot it down, tried to overwhelm its guidance systems with every countermeasure in the electronic warfare playbook. None of it worked. In the span of just 72 hours, Ukraine deployed a weapons platform that Moscow spent months preparing to neutralize, and when the smoke cleared, Russian air defense batteries across occupied Donbass were nothing but burning wreckage. Not damaged, not degraded, gone. This was not luck. This was not Russian incompetence. This was a deliberate technological leap that caught one of the world's most sophisticated militaries completely flat-footed. Welcome to States News. If this is your first time here, subscribe and turn on notifications because what I am about to show you is not just another story about another weapon system. This is about how Ukraine just fundamentally changed the calculus of modern warfare in ways that Pentagon analysts are still trying to fully comprehend. I am going to show you exactly what this weapon is, how it works, and why Russia's entire defensive doctrine just became obsolete in eastern Ukraine. We will cover the specific technical innovations that make this system nearly impossible to counter with conventional electronic warfare, the strategic implications for Russia's ability to hold territory it has occupied for 2 years, and the second-order effects rippling through NATO planning and global defense markets. By the end, you will understand why this single development has Russian military bloggers calling for wholesale reevaluation of air defense deployment, why defense contractors in 7 countries are scrambling to reverse engineer the underlying technology, and why the balance of power in the Donbass just shifted in ways that create genuine opportunities for Ukrainian advances that were impossible 3 weeks ago. To understand why this matters, we need to establish some critical context about electronic warfare and the arms race that has defined this conflict since February 2022. When Russia launched its full-scale invasion, one of its most significant advantages was electronic warfare capability. Russian EW systems like the Krasuka-4 and Jatel were designed specifically to jam GPS signals, disrupt communications, and render precision-guided munitions useless. For the first 18 months of the war, this capability forced Ukraine to rely heavily on unguided artillery and weapons systems that did not depend on satellite navigation or radio frequency guidance. The result was enormous ammunition expenditure for relatively limited accuracy. Ukrainian forces were burning through shells at rates approaching Soviet-era artillery tactics because precision guidance simply could not function in the electromagnetic chaos Russian systems created. Russia's doctrine here was straightforward and historically proven. Deny the enemy the ability to use precision weapons by controlling the electromagnetic spectrum, forcing them back to area saturation tactics that favor the side with more artillery tubes and deeper ammunition stockpiles. For much of 2022 and 2023, this worked. Ukrainian HIMARS strikes were devastating when they connected, but Russian jamming meant that a significant percentage of GPS-guided rockets missed their targets entirely or required last-minute manual targeting adjustments that reduced effectiveness. The same pattern applied to loitering munitions, commercial drones adapted for military use, and even some NATO-supplied precision artillery rounds. If it relied on GPS or radio frequency guidance, Russia could disrupt it to some degree. This created a genuinely difficult problem for Ukrainian forces and their Western supporters. Modern Western military doctrine is built almost entirely around precision strike capability. The ability to hit exactly what you aim at with minimal collateral damage is not just a nice feature. It is the foundational assumption underlying everything from air campaign planning to artillery tactics. Take that away, and you are back to 20th century warfare of mass and attrition, which heavily favors Russia given its population advantage and industrial capacity for producing simple, unguided munitions. Ukraine needed a way to restore precision strike capability in a contested electromagnetic environment, or risk being ground down in exactly the kind of war Russia was built to win. Enter the defense technology community that has emerged in Ukraine since 2022. While most coverage focuses on Western military aid, an equally important story has been Ukraine's rapid development of indigenous defense capabilities. Small technology firms, startup companies, and even volunteer engineers have been working in parallel with military planners to solve specific battlefield problems. This is not the Soviet model of massive state-owned design bureaus operating in isolation. This is a decentralized ecosystem where a professor at Kiev Polytechnic Institute might collaborate with a drone startup in Lviv and a military unit commander in Zaporizhzhia to iterate solutions in real time based on battlefield feedback. The cycle time from identified problem to fielded prototype has sometimes been measured in weeks rather than the years typical of traditional defense procurement. This ecosystem has produced everything from cheap first-person view kamikaze drones to naval surface drones that have effectively driven the Russian Black Sea Fleet from Crimean ports. But these systems, while tactically successful, still operated in categories Russia understood and had developed countermeasures for. Jamming systems could disrupt drone control links. Naval defenses could engage surface drones with machine guns and small-caliber cannon. Electronic warfare could degrade GPS guidance. Ukraine was winning tactical engagements, but within the existing framework of what was technologically possible. Russia could study each new system, understand its operating principles, and deploy countermeasures. The cycle would begin again. What just landed in eastern Ukraine breaks that cycle completely. The weapon system goes by the designation Vidsich, named after a Ukrainian folk hero known for unconventional tactics. According to reporting from Defense Express and confirmed by multiple Ukrainian military sources speaking to Ukrainska Pravda, the Vidsich is a ground-launched cruise missile variant that incorporates three specific technological innovations that make it extraordinarily difficult to counter. First, it uses a combination guidance system that blends inertial navigation with optical terrain mapping and does not rely on GPS at any stage of flight. Second, it incorporates frequency-hopping spread-spectrum communications that cycle through multiple bands faster than Russian jamming systems can track and counter. Third, and this is the element that has Russian air defense operators genuinely concerned, it carries an onboard electronic warfare package that actively targets the radar emissions of air defense systems attempting to track it. Let me break down why each of those elements matters. Inertial navigation is old technology, basically a very precise gyroscope and accelerometer that tracks movement from a known starting point. By itself, inertial navigation accumulates errors over distance and time. You launch from coordinates x, you know your speed and direction, you calculate where you should be, but tiny errors compound until you are hundreds of meters off target after a long flight. GPS fixes those errors by providing absolute position data. Jam the GPS, and inertial navigation alone becomes inadequate for precision strike. Optical terrain mapping solves this by using a camera to compare the terrain below to stored map data, essentially navigating by landmarks the way a pilot would do visually. This does not require any radio frequency emissions that can be jammed. The missile looks down, recognizes where it is based on visual features, corrects any inertial drift, and proceeds. Russia has this technology too, but implementing it in a low-cost cruise missile small enough to be mobile-launched is non-trivial engineering. Ukraine appears to have cracked this problem. The frequency-hopping communications deserve particular attention because this is where Ukraine has leapfrogged Russian countermeasures. Traditional drone and missile control links operate on fixed frequencies. Jam those frequencies with enough power and you break the link. The drone or missile either crashes, returns to base, or continues on its last known heading, usually missing the target. Frequency hopping means the control link rapidly switches between multiple frequencies in a predetermined pattern known to both the transmitter and receiver. Russian jamming systems would need to jam all potential frequencies simultaneously, which requires vastly more power and sophisticated coordination between jamming assets. According to technical analysis published by Mikhailo Zhirokov, a Ukrainian defense analyst writing for Defense Express, the Vidsich system hops between frequencies every few milliseconds across a wide spectrum band. Russian Jatel and Krasuka systems were designed to jam specific frequency ranges with high power. They were not designed to track and jam frequency-hopping systems operating across the full commercial and military radio spectrum. The jamming power gets diluted across too wide a range to effectively disrupt the control link. Now here is where this gets genuinely interesting from a tactical perspective. The onboard electronic warfare package means the Vidsich does not just resist jamming, it actively hunts Russian air defense radars. When a Russian Tor, Pantsir, or Buk air defense system activates its radar to track an incoming missile, that radar emits a very specific radio frequency signature. The Vidsich carries a radar warning receiver that detects this emission, identifies the type of radar based on its signature, calculates the location of the emitter, and can either feed that data back to Ukrainian targeting networks, or, in some configurations reported by Ukrainian sources, actually divert to attack the radar directly. This inverts the normal dynamic where air defense systems hunt missiles. Now the missile hunts the air defense system, and the Russian operators face an impossible choice. Turn on your radar to track and engage the incoming threat, and you broadcast your location to a weapon specifically designed to kill you. Keep your radar off, and you are blind to the incoming strike you were positioned to defend against. Think about what this means operationally. Russia has spent 2 years building layered air defenses across occupied territories. Multiple Tor and Pantsir systems positioned to provide overlapping coverage, Buk systems providing medium-range defense, S-300 and S-400 batteries providing long-range coverage, all networked together and coordinated with electronic warfare assets to create what Russian doctrine calls a non-penetrable air defense zone. This system has been reasonably effective against Ukrainian Air Force jets, attack helicopters, and earlier generation drones. But it was built on the assumption that Ukrainian weapons would be relatively simple, would rely on GPS guidance that could be jammed, and would not carry countermeasures sophisticated enough to threaten the air defense systems themselves. The Vidsich invalidates those assumptions. On April 9th, according to reporting by Radio Free Europe and confirmed by geolocated imagery, verified by independent open-source intelligence analysts, Ukrainian forces struck a Russian ammunition depot outside Horlivka in occupied Donetsk. The depot was protected by at least 2 Tor M2 systems and 1 Panzer S-1, positioned specifically to defend against exactly this kind of attack. Satellite imagery from April 10th, analyzed and published by Brady Afric of the American Enterprise Institute, shows the ammunition depot completely destroyed with secondary explosions visible in thermal imaging, but also shows both Tor systems burned out and the Pantsir abandoned by its crew. Ukrainian sources claim 3 Vidsich missiles were launched in the strike. One targeted the ammunition depot directly. The other 2 were programmed to attack any air defense radar that activated to engage the first missile. When Russian air defense operators turned on their radars to track the incoming threat to the depot, they painted targets on themselves that the other 2 missiles immediately exploited. This is not an isolated incident. Between April 9th and April 14th, Ukrainian forces have conducted at least 7 confirmed strikes using Vidsich systems against targets in occupied Donetsk and Luhansk. Of those 7 strikes, 5 resulted in documented destruction of Russian air defense assets that attempted to engage the incoming missiles. The pattern is consistent across multiple targets and multiple air defense system types. Russian operators are facing a weapon that their standard tactics cannot counter, and improvised responses like keeping radars off until the last possible second have proven inadequate because the Vidsich's terminal phase happens too quickly for effective engagement even with minimal warning. Russian military bloggers, usually reluctant to acknowledge Ukrainian successes, have been remarkably candid about this problem. Rybar, a prominent Russian mill blogger with connections to Wagner Group, posted on April 12th that air defense units in Donetsk are requesting complete reevaluation of deployment doctrine because existing positioning and engagement protocols result in unacceptable losses when facing the specific threat. Romanov Light, another well-connected Russian source, reported that at least 6 Tor and Pantsir systems have been lost in 10 days, with crews increasingly reluctant to activate radars even when targets are detected visually or through passive sensors. When your air defense operators are afraid to use their systems because doing so marks them for destruction, you have fundamentally lost air defense capability in that sector. The strategic implications extend far beyond individual tactical engagements. Russia's ability to hold occupied territory in Donbass has depended heavily on its air defense umbrella, preventing Ukrainian air support and precision strikes. Ukrainian ground forces might have local superiority in terms of motivation and tactical skill, but Russian artillery superiority and air defense coverage have created conditions where Ukrainian advances become prohibitively costly. Take away the air defense umbrella and the calculation changes dramatically. Ukrainian forces can bring precision strike capability to bear on Russian logistics, command posts, and artillery positions without accepting catastrophic losses to Russian air defense. This creates opportunities for offensive operations that were simply not feasible 3 weeks ago. We are already seeing this play out. According to reporting by Ukrainian outlet Hromadske, Ukrainian forces launched a limited offensive operation near Bakhmut on April 13th, supported by precision drone strikes and Vidsich attacks on Russian positions. The operation achieved its objectives of straightening the front line and capturing higher ground with significantly lower casualties than similar operations attempted in the same sector in February and March. Ukrainian commanders attributed the success directly to the ability to suppress Russian artillery and air defense without requiring massed artillery preparation that would have alerted Russian forces to the impending attack. Precision strike capability enables operational surprise in ways that conventional artillery preparation does not. The second-order effects are equally significant. NATO countries have been watching Ukrainian weapons development closely, both to understand what Ukraine needs and to identify innovations worth incorporating into their own arsenals. The Vidsich represents a solution to a problem that NATO has not adequately solved despite spending billions on research. How do you conduct precision strike operations in a contested electromagnetic environment against a peer adversary with sophisticated jamming and air defense capabilities? Western doctrine has largely assumed air superiority as a precondition, achieved through suppression of enemy air defenses using specialized aircraft like the F-35 or dedicated electronic warfare platforms like the EA-18G Growler. Ukraine does not have air superiority and will not achieve it anytime soon, yet has developed a ground-launched system that achieves similar effects at a fraction of the cost. Defense contractors in the United States, Poland, and the United Kingdom are reportedly seeking access to Vidsich technical specifications to understand how Ukraine achieved this capability. According to Defense News reporting from April 14th, at least 3 NATO countries have approached Ukrainian defense officials about potential co-production or licensing agreements. The underlying technology is not revolutionary in the sense of requiring fundamental scientific breakthroughs, but the integration and optimization for cost-effective mobile deployment represents genuine innovation. Western equivalents like the U.S. AGM-158 JSSM cruise missile incorporate similar features, but cost roughly $2 million per unit and require aircraft launch platforms. Vidsich is reportedly producible for under $300,000 per unit and launches from truck-mounted platforms that can shoot and relocate before counter-battery fire arrives. The cost-effectiveness creates tactical options simply not available with Western systems. There is also a psychological dimension worth considering. Russian military planning has operated on the assumption of technological superiority in certain domains, particularly electronic warfare and air defense. This assumption has been baked into strategy, tactics, and the propaganda narrative fed to both Russian military personnel and the domestic population. When a Ukrainian system renders Russian air defense ineffective not through overwhelming force, but through superior engineering, it undermines that narrative in ways that tactical defeats do not. Russian military morale has proven reasonably resilient to territorial losses and even significant casualties, but technological humiliation creates different pressures. When your soldiers and the public understand that the enemy is outthinking you rather than just outfighting you, it raises fundamental questions about military competence and leadership that are harder to deflect with propaganda about Western involvement or Ukrainian desperation. Let me step back and look at what this does not mean, because maintaining analytical precision requires acknowledging limitations alongside capabilities. The Vidsich is not a wonder weapon that ends the war or makes Ukrainian victory inevitable. Russia still holds significant occupied territory, still possesses enormous artillery advantage, still has the industrial capacity to replace destroyed equipment at rates Ukraine cannot match without sustained Western support. One weapon system.